Hello everyone, I am Adrenaline the Bazooka Prophet. Now, in this particular video, we're going to be talking about some GCSE questions in chemistry that has been a problem to many students. A lot of students do not know how to actually tackle GCSE questions. So, in this particular video, my interest, is going to be settling out GCSE questions. So without wasting time, pick the first one, right? As you can see on your screen. Question says the maximum theoretical mass of the salt that could be produced, right, using 50 cm cube of the sulfuric acid is 12.5 gram. The percentage yield of the salt is 92.8%. Calculate the mass of the salt actually produced. Now let us go straight to the video where I actually solve it. Then we'll be right back. Thank you. This question that is placed right here on your screen. And the question reads like this: that the maximum theoretical mass of the salt that could be produced using 50 cm cube of the sulfuric acid is 12.5. and that the percentage yield of the salt is 92.8%. The question asked us calculate the mass of salt that was actually produced. All right? And in this GCSE question, you were given the formula of the percentage yield, which is equal to the mass of the salt that was actually produced over the maximum theoretical mass of salt that could be produced multiplied by 100 over 1. It's actually very simple, right? So let us solve it. You are given the maximum theoretical mass, which is maximum theoretical mass will be equal to what? 12.5 gram. And you're giving the percentage yield, right, to be equal to what now? 92.8%. Actually very simple. So now from the formula of the percentage yield, we have to rearrange it because we are looking for the mass of the salt that was actually what produced. That is how easy GCSE questions are. What do we do here? Become the mass of salt actually produced will now be equal to what? The percentage yield multiplied by the theoretical what? The theoretical what? Yield, right? Multiplied by the theoretical yield divided by what now? 100, which is now equal to what? 92.8 multiplied by the theoretical yield, which is 12.5 divided by what now? 100. You do that together, you have your final answer to be what? 11.6 gram of what was theoretical, what was actually what produced, right? So move straight to other questions, right? Thank you and God bless you. Now the next question is simple, and the next question says some salts can be produced by reacting sulfuric acid with a melter. And I said neither copper nor sodium is used to produce a salt with sulfuric acid. Give one reason why each melter cannot be used. Give one reason why each metals cannot be used. It's actually very what? Simple. Now the question asks why copper and sodium are not used to make salt with sulfuric acid. Now, why can't copper be? Now, copper cannot be because it is less reactive than hydrogen, so it does not react with dilute sulfuric acid. Take note. And if you are to answer it, you just simply write your book that copper is less reactive and does not react with sulfuric acid because it is below hydrogen in the reactivity series, right? So metals that hydrogen is higher than cannot displace hydrogen in the reactivity, in the chemical reaction. Now, why can't sodium be? The reason because sodium is too reactive. Sodium is too reactive, and as such, it reacts violently with acid and can be dangerous. So simple. You have to write it in your answer booklet. It will be sodium is too reactive, right, and react violently or dangerously with sulfuric acid. You understood now? Now, the shortcut is very simple. When too low in reactivity, take note, when it is too low in reactivity, there will be no reaction. When it is too high in reactivity, it is dangerous reaction. That is how you can simply jot it down. This, what I'm explaining right now to you, can also be relevant for students who are preparing for AP chemistry exam, IB chemistry exam, or Cambridge O level. So the shortcut is, when a reaction is too low, there will not be reaction. If a reaction, if the element in particular is too high in reactivity and is dangerous, and as such, it is often not utilized by doing so. Understood now? We'll move straight away to the next question, which is what now? 2.1. 2.1. Now the question says, give one similarities, right? Give one similarities and one differences between the electronic structure of sodium and potassium. Give one similarities and one difference between the electronic structure of sodium and potassium. This is actually very, very simple. So how do we answer this question without actually matching lines? Now we should understand that the electronic configuration for sodium is 281 because sodium has an atomic number of 11, and as such, both the protons and the electrons are equal. So if we are to write the electronic configuration, we'll be having it to be what now? 281. By that of potassium, it will be what? 2881, because the atomic number for potassium is 19. And when we write the electronic configuration, it will be 2881. Now, for us to actually go deeper, we will ask, what is the similarity? The similarity is that both sodium and potassium have one electron in their outer shell, which makes up the valence electron for sodium and potassium to be one, and which also forms the group of the elements. Understood now? Do not cram it. This is GCSE Special Otekwete Summit. Now we move straight away to what do you think should be the differences from what you have. The number of shells that is formed in sodium is 3, but 281, that's 3 shells. But that of potassium is 2881, which is 4 shells. And as such, that makes up the differences. Now, without making the videos too long, we'll break it in bit by bit. Do it to like, share, and subscribe. And for online tutorial classes for your exam, do it to contact us today. Thank you and God bless you.